Alright, so, which one do I want to do? Let's do 11. Alright, so for 11, we have cosecant theta over 1 plus cosecant theta equals 1 minus sine theta over cosine squared theta. And please give yourself plenty of room when you're doing these problems because, like, this one in particular is going to take quite a bit of room. Alright, now there are ways I could work on either side of this problem, but which one do you guys think you would start on first? Okay, I'd probably start on the left because you've got those cosecants, right? And typically we don't like to have cosecants. So, cosecant is 1 over sine theta. And you may even, like if you've got a different color pen or something, you might want to put yourself like a line between each step, especially when you're dealing with these complex fractions, because it's easy to get mixed up what's the numerator, what's the denominator. You might want to put some parentheses around the numerator and denominator to keep it straight. So, I'm going to do a red line in between each step on mine, just so it doesn't run all together here. So, we do not like to have complex fractions. We don't like to have fractions inside of fractions. And we can see over here clearly you don't have a complex fraction here, so it's not going to match. So we need to try to do dividing fractions easy as pie, flip the second, and multiply. The problem is our second fraction, it's really not a fraction, right? It's not a single fraction. It is 1 plus 1 over sine theta. So I cannot flip that second whenever the whole thing is not a fraction. It has to be a single fraction. So what I need to do first here is I need to get some common denominators. So right now that's just over 1. So what were you saying? No, you can't do that. So what you're going to do is you're going to multiply the 1 over 1 by sine x on top and bottom. Or I guess it should be a theta. Use the theta. So, keep the numerator the same, 1 over sine theta. Even though you're only doing work on the denominator right now, don't get rid of it. So, this is going to give you sine theta plus 1 over sine theta. Because once I multiply and get that common denominator, I can just write everything over sine theta. Okay. Questions so far? Okay, so now I have a fraction over a fraction, right? So now I can say dividing fractions is easy as pie. I'm going to flip the second and multiply. So I'm going to have 1, let me do another red line. This is the next step here. 1 over sine theta times sine theta over 1 plus sine theta. Alright, so it's really important that you understand what you can and cannot cancel here. Can I cancel this sign with this sign right here? this sign with this sign right here. I'm seeing Lauren shake her head no. She is correct. I cannot cancel this sign with this sign right here. Because right here, I've got this plus sign between my 1 and my theta. But, can I cancel this sign with this sign down here? I can. And the reason that I can do that is because this stuff is multiplied together, right? So, in order to cancel, your factors have to be multiplied together. It can't be added or subtracted. So, I can cancel this sign with this sign right here. And so that is going to give me a 1 in the numerator and a 1 plus sine theta in the denominator. Which stinks because it does not match the other side. You cannot cancel the 1s because you are in this expression, you got 1 plus sine theta. So you got that plus sign right there. These are multiplied, but it's like there's parentheses around this whole expression. So you can't cancel just like a piece of that expression there. If in the top we had 1 plus sine theta, and then on the bottom we had 1 plus sine theta, we could cancel the whole expression. But we can't cancel just like a piece of it. So, this looks better than it did to start with. We've got sines, but it does not match what we have over here. So, when this happens, I do know a way because I have taught this for a very long time and have seen lots of different ways to solve this. I do know a way to get to what we have over here. But it's not the most straightforward way and not what I would suggest for you guys. So, instead of trying to keep working on this side, let's go over to this side and see if maybe we can get it to match 1 over 1 plus sine theta. And so immediately I notice that over here on the left, I only have sine. But over here, I've got sine and cosine. So probably I don't want that cosine. All right, I probably want to get rid of that cosine. So what can I replace cosine with? I can do 1 over secant, but it is not going to really get me anywhere on this. Because secant would still be like a cosine, plus there's no like secant over here on this side. Not sine squared plus 1, but you're close. Cosine squared, so this is like a over to the side thing here. Cosine squared of theta always equals 1 minus sine squared theta. So that would change everything to where I only have sines that I'm dealing with. So 1 minus sine theta stays the same on top. I'm going to change the denominator to 1 minus sine squared theta. Now, can I really want to, and it seems like I should, lock this in place. I really want to take this sign, cancel it out, make that just 1 sign. And that would give me, well, that's going to give me 1 over 1 minus sine theta. Does that match the other side? It wouldn't be a negative 1 because that minus is after. This is completely wrong, so you don't want to do it this way anyway. But it's close to matching, but it doesn't match, and we can't do this. Why can we not do what I just did? There's one under Bo's desk there. I don't know who it belongs to, but. So why can I not cancel one of those signs? It's because of this 1 minus right here. So 1 and sine are not being multiplied, right? So you've got plus or minus signs in that top and bottom. So the things that you're canceling, it's not being multiplied. So we cannot do that. So here is a strategy that we need to like catalog away in our brains, because obviously I need to just have a 1 plus sine theta here. I got to cancel something, right, to get down to this. So to catalog away in your brains, if you see 1 minus sine squared theta, this is just like over to the side here, it will factor into 1 minus sine theta times 1 plus sine theta. It's a difference of squares. Like if we were taking 1 minus x squared, we were factoring it into 1 minus x and 1 plus x. So what we can do is now we can write this as 1 minus sine theta over, we can factor that denominator, 1 minus sine theta, 1 plus sine theta. Okay, now I have multiplication between these two terms here, right? 1 minus sine theta matches the 1 minus sine theta on top. Now I can cancel those entire terms. And since there's nothing left on top, we would put a 1 there. And the bottom we'd have 1 plus sine theta, which matches the other side. So we know we've done that correctly. Okay, questions? Alright, so I want to do one more. Let's do 14 together. Or do I want to do... Let's do 14 for right now. Okay, so for 14, I've got cosecant of theta over 1 minus cosine theta equals 1 plus cosine theta over sine cubed theta. Okay, so which side do you guys want to work on first? Left. Left is probably a good choice, especially for you guys at this point. We've got a cosecant, and usually we need to get rid of a cosecant, right? And over here on this side, I got a sine cubed. I don't even know what to do with a sine cubed, really. So I'm going to hold off on that and hope that maybe I don't have to worry about it, but I might. All right, so cosecant is 1 over sine theta. Now we have a complex fraction. So for complex fractions, dividing fractions easy as pie, flip the second and multiply. The bottom's not a fraction, so how do I make it a fraction? Put it over 1, and so I will have 1 over sine theta times 1 over 1 minus cosine theta. Alright, now if I multiply it together, 1 times 1 is just 1. In the bottom, I'm just going to have to write it like this, sine theta times 1 minus cosine theta. Make sure, whenever it's written like this, that you've got parentheses around that 1 minus cosine theta. You can get away with not doing it in this step because they are separate fractions, but if you put it there, it won't help. You've got to have the parentheses down there on that bottom step. You could distribute the sign, but in general, it is not helpful to distribute the sign because if you distribute the sign, a lot of times things won't cancel like you're wanting it to. But I don't know what else to do with that, and it doesn't match the other side. So this is going to be another one where we need to do some work on both sides. Anybody have an idea of what we could do with that sine cubed? Because I know I got to get rid of that sine cubed somehow. It is not 1 minus cosine squared because of the cube. But that's the direction we need to go in, right? If we got 1 minus cosine squared, then we could factor and we could cancel with that numerator. But I cannot write 1 minus cosine cubed theta. It doesn't work. Pythagorean identity only works if it's squared. But is it correct to write this? 1 plus cosine theta over sine theta times sine squared theta. There's not one written here, but there's only one sign here. If I multiply it by 2 here, it'd give me 3 altogether. So I can sort of break those apart. So that sine squared, I can change it to 1 minus cosine squared. So that will look like this. Questions so far? Ideas? It's helpful sometimes to look at the other side. Look what we got here. They're almost the same, right? Except for instead of this cosine, that cosine's not there at all. And instead of this being squared, it's just to the first power. What? Can I cancel out a cosine? So whenever, and this is the hardest part of this. I cannot cancel that cosine because this plus sign is minus sign right here. What do you think, Zach? That I can do. So the top is 1 plus cosine theta. I'm going to put it in some parentheses there. And in the bottom, 1 minus cosine squared theta, I can factor it into 1 minus cosine theta times 1 plus cosine theta. Now, I could not cancel up here because I had these plus and minus signs involved in what I was trying to cancel. But now I've got this whole expression, x plus cosine, 1 plus cosine theta, and this one, 1 plus cosine theta, and everything's being multiplied here, right? There's a plus sign inside, but not between the things I'm trying to cancel. So I can cancel them at this point. This step has to be shown. If you don't show where you factor that, then I'm going to assume you just canceled those cosines incorrectly and did not get full credit on it. And then so there's still going to be a 1 on top there, and we'll have sine theta times 1 minus cosine theta, and that equals what I have on the other side, so I know I've done it right. So these should be some like strategies that you're storing away in your brain, because these are tough. Because there's no manual where I can tell you every time you see a sine cubed you need to break it into a sine and a sine squared. But you should be thinking, if I have a sine cubed, maybe I should break it into a sine and a sine squared, right? You should be thinking, if I see 1 minus cosine squared theta, maybe I should factor it, especially if it looks like it'll cancel with something on the top. You should be thinking, when I have complex fractions, I probably need to flip the second and multiply, right? So these are just strategies that we see here that hopefully we can apply to the next problems that we do. Okay, questions? Now, I could sit up here and do these for a while. Hopefully you're at least following where I'm going with this. Even if you could not come up with it on your own, once I do it, you understand what is happening. That's where I need you to be right now. What we're working towards, though, today happening is you can see where to go on your own. So really, the best thing to do for this is just to do a lot of practice without me showing you how to do it, because I am really good at these. I can do these really well. I find very few of them that stump me, because I've done them for a very long time. So I'm pretty good at these and can do them pretty quick and can do them several different ways. But that means nothing if you can't come up with steps on your own. So what I want to do is I want to take 15 minutes right now, and I want you guys to work completely on your own. Okay? I'm not going to help you. Nobody else is going to help you. You can't work together. We're going to do this for 15 minutes. Okay? If you get stuck on a problem, give yourself a pretty good amount of space and try a different problem, okay? Because I promise I am going to help you eventually, and I am going to let you work together and help each other eventually. But sometimes you need a moment on your own to think about where do I even know where to start with this, okay? So for 15 minutes until 12:40, you guys are going to work on your own on these problems here. Then, after that's up, I will come around to help. You may sit with somebody that you want to work with if you want, and you can work together. But I want to take 15 minutes of you looking at this and trying something on everything. Yes? You can work on some of the first ones if you want, instead of the later ones if you want. And they are on the board if you want to kind of let that guide you. Okay?